So hello guys, welcome to this class. This is the first class in physics. We will be following strictly Jamb syllabus and sometimes Y and SS. So this class will be talking about the first topic in physics that is important, which is called fundamental and derived units. Fundamental and derived units. So fundamental quantities are 3, 4, 5, 6. They are the basic unit of measurement. Fundamental quantities, you can write it down. Fundamental quantities, these are the basic unit of measurement. Under fundamental quantities, other quantities are being derived, right? So the first fundamental quantity is mass. The unit for mass is kilogram. We are talking about physics now. The unit for mass is kilogram, and the abbreviation for kilogram is kg, right? After mass, the next one is length. The unit for length is in meter. Make sure you write this thing down. The unit for length is in meter, and it is abbreviated m. For time, the unit for time is in seconds. Time is in seconds, and it is abbreviated s. The next one is luminous intensity. Luminous intensity. Luminous intensity is measured in candela, and the symbol is C. The next one is temperature. Temperature is measured in Kelvin, and the unit is K. And the last one is electric current. Electric current, and the unit for electric current is in amperes, and the symbol is A. So these are the 6 basic fundamental quantities that are very important in physics. Now let's talk about derived quantities. Derived quantities. What are derived quantities? Derived quantities are the unit of measurement that are derived from the fundamental quantities. For example, now let's say area. How can we get the unit of area? Now let me teach you a trick. To derive a unit, you must first of all know the formula of the quantity. We know that area is the same thing as length times breadth, right? So length, the unit for length is a meter, and breadth also is talking about length. Both of them are length, breadth. So both of them are talking about length. So this is the same thing as, so you replace the length with the meter here, and you replace the breadth with its equivalent unit, which is also meter. So meter times meter will give you meter square. So that is how you have successfully derived the unit of area from the fundamental unit. Let's take another example. Velocity. To get the unit for velocity, we must first of all know the formula for velocity. Don't worry, as we begin to progress, you begin to know more formula. So the formula for velocity is displacement over time, and the fundamental unit for displacement is meter m. and the fundamental unit for time is seconds, right? So meter per seconds becomes the unit for velocity. So it's very easy. This is how we derive fundamental units. So without wasting time, let us list the type of fundamental. So we talk about area. Area is meter square. Volume is meter cube. Density is kilogram. Hope you know how we derive this. The formula for density is mass over volume, right? So mass is kg. Volume, we already know volume as what? Meter cube. So it becomes kg over meter cube. So density is in kilogram meter cube. Velocity, I should write those things down, it's very important. Velocity is meter per second. Acceleration is meter per second square. Momentum, the unit for momentum is kilogram meter per second. So you study this, it's very important. So there are more and more, but these are some familiar derived quantities. When we begin to study further, we begin to see more and more. But the most important thing is you knowing how to derive the quantity yourself. Let's say, for example, we have a formula for pressure. We have the formula for pressure. The formula for pressure is force. Okay, let's leave this first. We'll go back to this later. Now there are some units that are not. There are units. There are some. There are some units that are not derived from the fundamental quantities. There are some quantities that are not derived from the fundamental. There are some quantities that have their unit not derived from the fundamental quantities. Their unit was given as a result of scientists who contributed to those quantities. So the units were replaced by the names of the scientists. Example is force. The unit for force is Newton. The symbol is N. Another one is energy. The unit for energy is joules. The symbol is J. The other one is charge, which is Q. The unit for charge is coulomb, C. The other one is frequency. The unit for frequency is Hertz, Hz. After frequency, we have resistance. The unit for resistance is ohms, and the symbol for ohms is like this. After that, we have capacitance. And the unit for capacitance is farad. The other one is inductance. The unit for inductance is Henry, which is H. Then the last one is pressure. There are more, but these are what I can give for now. And the unit is Pascal, which is PA. So I think let's keep this class as short as possible. Next class we'll be solving some Jamb questions that relate to this topic, so we know how we can solve questions that are related to fundamentals and derived quantities. Thank you very much. Make sure you share, watch over and over again to understand the concept. Thank you.